Hi guys, let me take a few minutes and finish this example with you. So let's also total up the buyers. So 7 and 9 makes 16. 41 and 29, that makes 70. 7 and 4 adds to 11. So notice, if you add the females and the males together, there are a total of 97 observations, 97 students in this data set. You should get the same thing if you total whether people buy, bring, or don't eat lunch. So that also adds to 97. So I also am going to look at overall, what's the percentage that buy their lunch at school? So again, that's just 16 divided by 97. So if you round that, that's around 16%. 70 out of 97, again, it should be close to about 70%. It's 72% if you round it. And then 11 out of 97, that's about 11%. So again, there's a little bit of rounding error here. Those only add up to 99%. That's okay. When we're rounding, sometimes that will happen in a table when we're working with percentages. So a couple of things to think about here. There is a difference between what's called a marginal distribution and a conditional distribution. So for instance, these are the margins here. Margin, the totals. This is also part of the margin. Literally, it's in the margin or the boundary of the table. We call the totals essentially the margin. And these percentages here are the marginal distribution. Excuse me. Let me spell it. M-A-R-G-I-N-A-L, the marginal distribution. Because we're working with the totals, so literally, amongst all of the students, if we ignore gender, 16% buy, overwhelmingly, people tend to bring their lunch. 11% don't eat lunch at school. Now that's a marginal distribution because it's made in the margin of the table here, in the edge of the table, by using the totals. Here, what I've shaded, these are called conditional distributions. This is a conditional distribution. That is a conditional distribution, and so is this one. So under the condition that you are female, so looking only at the females, 13% buy, 75% bring, and 13% don't eat their lunch at school. So those percentages are different from the marginal distribution because we're not looking at everyone, we are looking only at the females. So under the condition that someone is a female in this data set, there is the distribution of their percentages. Same thing here, under the condition that we only look at males, 21% buy, 69% bring, and 10% don't eat their lunch at school. So those are called conditional distributions. And the conditional distributions are important because that's where we can look for a connection between gender and, if you will, choices at lunchtime. So is gender associated? I didn't know how else to put it to, I call it lunch behavior. I suppose you could say lunch choices. So in other words, if you knew someone's gender, would that help you predict someone's lunch behavior? Well, when I say that, if you compare the conditional distributions overwhelmingly, it really doesn't matter. Whether you're female or male, overwhelmingly, people prefer to bring their lunch to school for whatever reason. So males, if I had to choose, males tend to buy more than females do, although it's very, very close. The percentage of females that don't eat lunch at school is just slightly higher than the percentage of males that don't eat their lunch at school. But overwhelmingly, when you compare the percentages, clearly gender doesn't matter in terms of whether you bring your lunch to school or not, because that's the overwhelming preference. The only place where I see the percentages even differing a little bit is regarding the buyers. 21% of males buy, whereas it looks like about 13% of females buy. So when we talk about an association, literally what we want to do is compare the conditional distributions. So these are what we are comparing. Compare those conditional distributions. So if I were to write this, I would say overwhelmingly, both genders prefer to bring. Overwhelmingly, both genders prefer to bring. So again, the 13 and the 10%, those really seem pretty close to me. The only difference that I see that's remotely interesting is the buyers. So the percentage of males that buy their lunch is higher than females. The percentage of males that buy is higher than for females. Notice, when I wrote that, I didn't actually use the percentage in my writing. What's important when you write is that you have context. So we're talking about comparing percentages, and it's about buying lunch. And we want to use, when we write, comparison terms. You don't actually have to report the numbers. What's important is to report the comparison. I suppose if I wanted to report a more dramatic comparison, I could be more specific about these two. So notice, females, 13% is pretty close to 14%, and the reason I mention that, this 14% is 2 times 7. Well, 21% is 3 times 7. So the truth is, if I wanted to be more dramatic about the comparison, I could say the percentage of male buyers is 50% higher than the percentage of female buyers. So that's, in fact, pretty close to a true statement there. I mean, it is approximately true. So what's important is the comparing of the conditional distributions. So another thing that you could do when you're making a comparison is you can make a graph. So I suppose I could title this lunch behavior or lunch choices. I think I prefer the word choices to behavior. So literally, we're just going to graph the percentages, and the highest percentage that we have is 75%. So here, I'll graph this by 10. So here's 10%, here's 20%, 30, 40, 50, 60, 70, here's 80%. So I'll put females first and then the males. So for the females, 13% buy, and it's important to label this. So 13% buy, that's just approximate. So 75% bring their lunch. So if this is 80%, wow, 75% is a pretty tall bar. Here's the bringers. And then it's only a little over 10% that don't eat. So again, 13% don't eat. So I can graph the same things for the males. So for the males, 21% buy. So here are the buyers. The bringers, about 70%, 69%. And the people that don't eat, it's around 10%. So when I made my graph, I mean, it's pretty clear for both females and males. The highest bar is the bringer bar. The don't eat bars are pretty similar. The buyer bar for the males is, actually, it's about 50% taller than the buyer bar for females. So I think the most interesting observation here is clearly bringing is overwhelmingly the preference. If I am going to look for a difference, I would say the difference is not as overwhelming in terms of the people that choose not to eat. It's about the buyers. And you don't even have to organize your graph this way. It would be perfectly fine to put both of the buyer bars together, but if you did that, you would have to label which is for the males and which is for the females. You could put the two bars for the people that, the percentage that choose to bring their lunch together. You could put those next to each other as long as you label which is male and female. And same thing for the people that don't eat their lunch. You could put those bars next to one another. Again, it's just important to label which one is male and which ones are for the females. You could also make a key, so you could shade it like this. You could say those are the buyers. You could shade the other way for the bringers if you wanted to. That's a perfectly acceptable thing to do, not just in the class, but on the AP exam. And then, I don't know, you could fill this one with dots or some other symbol, I suppose, in order to distinguish that. So what's important is that you just communicate so that it's clear the comparisons that we can make in terms of the graph.